In this video, we will analyze and graph the function r of x is equal to x squared plus 3x plus 2 all over x. So I think that the top can be factored, so I'm going to start there. So r of x is equal to, so I know that my first term in each set of parentheses is just going to be x because I just have x squared there. And I've got to have 2 and 1 for my second number because the only factors of 2 are 2 and 1. And they would both be plus because it's a positive 2. And my middle term is also positive. So the only thing left to check is, do I get 3x for the middle term? Well, 2x plus 1x gives me 3x. So I have it factored correctly. All right, moving on to domain. Remember, for the domain, you set the denominator equal to 0, or I'm sorry, not equal to 0. So there's really no work to be done for this one because it's just x. So the domain is all numbers except for 0, which we write in interval notation as negative infinity to 0 and 0 to infinity. Now to find the intercepts, remember that to find the x-intercept, you let y equal 0. And for a fraction, the fraction is equal to 0 when the top or the numerator is equal to 0. So I have x plus 2 equals 0 and x plus 1 equals 0. Sorry, I got carried away with my pluses there. So x is equal to negative 2 and x is equal to negative 1, both of which are in the domain because the only number that's not in the domain is 0. So I have two x-intercepts, negative 2, 0, and negative 1, 0. To find the y-intercept, I'm going to let x equal 0. And I'm going to use the unfactored. Oh, wait a minute. I can't let y equal 0. I'm sorry. I can't let x equal 0 because 0 is not in the domain. So x cannot equal 0. So what does that mean? Well, that just means that there is no y-intercept. All right. Now we look for holes. Well, there are no holes. To be a hole, there would have to have just a single x term multiplied by all this. So there are no common factors of x, so there are no holes. Now you might be thinking, but Miss Murphy, this term has an x in it. But remember that you cannot cancel across addition. So they would all have to have an x in it, and you would have to be able to factor out the x to be able to cancel that x. So if they all had an x term in it and you could factor it out, then there would be a common x. But since this term does not have an x in it, they do not have an x in common, so there are no holes. So now we look at vertical asymptotes. Remember, vertical asymptotes go hand in hand with the domain. So the vertical asymptote is going to be x equals 0. Now for the horizontal asymptote. So remember, we look at the degrees. So this we set the denominator equal to 0. This we look at the degrees. And we want to see if it's top heavy, bottom heavy, or the same. So if we look at the function, the degree of the numerator is 2. The degree of the denominator is not written, so it's understood to be x to the first. So this one is top heavy. And when you're top heavy, it's going to cause you to bend over or slant. So that means this one has a slant or oblique, which is another name for slant asymptote. And to find that, we're going to divide. And this one, you might think, well, this one is not in the form x minus c, so we cannot use synthetic division, but it is. We can write x in the form x minus c by writing it as x minus 0. So we're going to put 0 here in the box, and then the coefficients are 1, 3, and 2. So I got those from the numerator, 1, 3, and 2. It was kind of tricky, but it makes sense, hopefully, if you think about it. So now I'm going to bring down the 1. 0 times 1 is 0. 3 plus 0 is 3. Technically, I can stop there because these are the only two numbers I need. But it goes against my grain to stop there. 0 times 3 is 0. 2 plus 0 is 2. But remember, we throw this away and we only use these numbers. So our slant or oblique asymptote is y equals 1x plus 3. Which tells me that my slope is 1, because remember that's the number in front of x, and then my y-intercept, or b, is 3. All right, so let's put all this together and start graphing. So I do have a vertical asymptote, and that is the y-axis. So I'm going to go ahead and draw a dotted or dashed line on the y-axis. And I did have a slant asymptote. Now don't forget how to graph a line. Remember the y-intercept was 3. So I'm going to go up to 3 and draw a point. The slope was 1, so from there I can go up 1 over 1, or I can go down 1 and back 1. And so I'm going to draw a dashed line. And so I can use this dashed lines as my guides. And now I do have a few points, I think maybe 2. I had an x, 2 x-intercepts, -2, 0, and -1, 0. Now I know that it's not going to turn and go back up, so this must come this way, and this must come this way, and it's going to come and go through there. But I'm not sure what's going on over here. So let me pick a few values. Maybe +1. Let's see, what did I use? Let me use 1, 2, 4, and I also used 1/2. Now remember, to get these values for y, what you're doing is either plugging them in the factored form of your polynomial or your rational function, or the unfactored form of your rational function. And it's okay to use your calculator to get that. When you plug in 1, you should get 6. You'd have 1 plus 2 is 3. 1 plus 1 is 2. 3 times 2 is 6. And 6 divided by 1 is 6. When you plug in 2, you actually get 6 again. When you plug in 4, you get 7.5. And when you plug in 1/2, you get 7.5. So let's plot those. So 1/2 is 1, 2, 3, 4, 5, 6, 7.5. 1 is 6. 2 is 6. And 3 was 7.5. So it's going to come down here and swing back up like so. And that's the graph of the rational function.